Today's problem is going to be Leetcode 20 valid parentheses. You're basically given a string S and it has opening and closing parens, and you need to determine whether the string is valid or not. So it's valid if there's an equal amount of opening and closing parens of a specific style. You've got round, curly, and square. Notice here this would be valid because you have an open round paren and then a closing round paren. This would also be valid. This would be false, obviously, because these are two different styles and there's not an equal amount of the same style, and then this would also be false. So the first thing I want to do is create a stack. A stack is the type of problem where it follows a LIFO data structure. So I'll make a stack here. It's just an empty array at first. Let's say I add a bunch of letters to my stack. So I add an A, and then I add a B, and then I add a C. Notice that the A is at the base, the B is at the middle, and the C is the very last item that I placed, or letter that I placed inside my stack. Now, if I was to pop off the stack, the first thing that I'm going to pop off or grab would be the last thing I put in. That would be the C. If I was to do this operation again, it would be a B, and then finally an A. So that's the LIFO orientation of the data structure of a stack. The next thing I want to do is create a object to store closing parens as keys and then use opening parens as values. This is going to make more sense when we loop over the string. So I'm going to say const map that, and then I'm going to have a closing paren, and then I'll do a curly closing paren, and then finally a square bracket closing paren. So this is going to be helpful when we loop over the string. I can basically check if the value is one of these, if the key is one of these, and then the value must be one of these. Now let's loop over the string. Just a simple for loop here. And to make it simpler for understanding what's going on, I'm going to say let char equal s at index I. If the char is an opening paren, then I want to push it to my stack. Push just means you put it into the stack. And remember, it's going to follow that last in, first out order that I showed you before. So if char equals an opening paren, there's the round one, got to do the curly, or char equals a square opening paren. Then we want to push it to the stack. If it's not one of those values, then we need to check if we can delete it or pop the stack. The way we can do that is we can say if the stack, the last item on the stack, how would we grab the last item on the stack? It's just an array, so we can just grab the stack.length -1 as the index right here. And then now we'll say if it doesn't equal map at index char. So remember, our map is just keys of closing parens with values of opening parens. So it's like map closing paren equals an opening paren. In our else conditional, we're only going to have access to the closing parens, right? So let's say we've already pushed, in our first iteration, we push an opening paren right here. We push this. Now, the next iteration, because right here we're going to push that opening paren, the next iteration of the for loop, we reach the closing paren, and we come down to this logic here. We're going to say map at, we're going to look this up, at closing paren, and then compare it to this stack, and that should be an opening paren of this. So if this opening paren is at the top of the stack, when we make this comparison, that's good, but if it's not, we need to return false. If it does happen, then we know we've closed the paren and we can delete it. So we can just call stack.pop. And pop actually mutates the array, so I don't need to say something like stack equals stack.pop. I can just say stack.pop and it'll automatically delete that last item. Okay, and then we need a way to check if it's truthy or if we should return true, because we have a condition to return false. The way we would know if it's true or not is if the stack.length is 0, because imagine we don't want anything remaining in the stack. If everything is gone, then we know there was an equal amount of closing and opening parens that matched up to each other, and the string is valid. So we can just say return stack.length equals 0. Let's see what we did wrong here. Oh, well, I gotta put my return statement outside of my for loop. Now let's run it. And there you have it. There's our answer. The time complexity of this problem is going to be O of n because we are looping through the string directly proportional to the amount of inputs. And then also the space complexity is going to be O of n because we're creating a stack in which we place all of our inputs and we delete that stack item by item. So I hope you guys enjoyed this video and found it valuable. If you did, make sure to like and subscribe. I will see you in the next one.